So welcome to the video lecture series on network theory. This is lecture number 61. So today again it will be a revision class. Okay. So in today's class, okay. Okay. So now, so here onwards, I will be taking the possible question paper. How many question papers we can solve? We'll solve that. Okay. So we shall keeping third eye in mind. So I will be concentrating now the coming classes, whatever we take before third eye. Okay. So I would like to concentrate on module number 3 and 4. Okay. So module 3 and 4. Okay. So that is what we have learned is the transient analysis and Laplace transform. Okay. So I would like to start it from way back from 2004 question paper. Okay. So in 2004 scheme was different. So it was not like your modules. So we used to have units, unit 1 to 8. So in that Laplace and transient, they were under the one unit. Okay. So usually question number 6 and 7, if you take out, so they belong to transient and Laplace transform. Okay. And there are minor changes in the syllabus what you are studying. Okay. So you don't have this, what you have, convolution theorem and all. Okay. So it was there at that time. Okay. Anyhow, now today I will be discussing probably, possibly I have planned for 3 plus 2 plus 2. Okay. Maybe around 5 to 6 questions from question paper 2004. Okay. Okay. Is that clear now?
Yes, sir. Yes, sir.
Yes, sir.
So first I would like to take it from as I mentioned the year. So in 1 year you will get two question papers. So one is regular and one is arrears. So anyway, if you take 2004 January, February. So this is January and February. So you can just look into those question papers also. So some portion is not there. So those questions I am skipping. Okay. So now in this, if you take question number 6. So question number 6a, under 6a. So it is being asked to like establish the procedure for evaluating, establish the procedure for evaluating initial conditions okay with examples. Okay, this was asked for 6 marks. Sorry, 8 marks. So what is the expected answer here? So everyone, are you able to see that question there? This one? Establish the
Yes.
procedure for evaluating initial conditions with examples. Okay. So what is the possible answer? So what about you? You are thinking here. You can type in the chat box here. Yes, quickly, everyone. I want reply from everyone. 37 students. 1 minute. Hmm. I'm not asking. Describe what you will be writing. Yes, please do that. Complete that in the chat box. Yes. Yes, everyone, type your possible answers. So what you want to write there in one line. Am I audible or no?
Yes.
What's the problem? Answer. Type no. How much time you want to type there? Abhishek, Aditya, Akhila, are you there? Akhila Galgali.
Yes, sir.
So what I told? Anis, Lubana, Anup. Are you getting what I'm telling? Anup, Arpita, Anup, are you there? Okay. Yeah, everyone, are you? Am I audible or no?
Yes, sir.
What I told.
Yes, sir.
So what did I ask you people to do, and what people are doing? Don't type for entire answer. Just type the highlight in one line. Vaishnavi. Okay. Hmm. Basavaraj, I think Basavaraj, are you there?
Yes, sir.
Okay, you have written t equal to 0 plus and t equal to 0 minus, right?
Yes, sir.
Okay,
Else
so
equal to else, sir.
ah,
Find T0 plus and T0 minus.
yeah, that only the behavior of inductor, capacitor, and resistor for t0 plus and t0 minus. Okay,
Sir.
so that table you have to describe. Sakshi, Sakshi, yes. Okay, so no need to write LCR circuit. Just describe each component. Okay, inductor behavior, how it behaves for t equal to 0 and t0 minus initial condition, final state. So that table you have to explain. So Akila, so I think inductor replaced with current source. So okay, that condition also we have to include. So overall, everyone, are you getting the uh, answer here? So what you have to write here? You have to write, you have to use the table component, or better you write element rather than component. RLC. So how it will behave for t equal to 0, t equal to 0 plus, or you can also take it as something like steady state, 0 minus, steady state for infinity and minus infinity. So which one is open and which one is closed, so that you describe here, okay, along with the circuit. So you can take, I think Sakshi, you are telling this one, no?
Yes, sir.
So you have to take them individually, not in a single circuit for different elements. Okay, okay, that is fine. So okay, I think I got 3 reply. How many are there totally? 39. 3 out of 39. What about others? Yes, what about others? Are you understanding the question now? Everyone?
Yes, sir.
Yes, sir.
Yes, sir.
But why don't you reply there in the chat box? I told. No? Whenever we ask to reply, do it in time. See how much time we lost here, 10 minutes. Okay, fine. Now, let us not stick to this only. See, this is the only one theory question what you can expect in the transient analysis, this table. Okay. So now if I go to the next one, question number 6b from the same question paper. Okay. So it was question number 6b is of 6 marks. Okay. So they have given this circuit. This is the given circuit. V equal to 10 volts. R is there, inductor and capacitor. Okay, and this is given. Okay, so R value is 10 ohms. This is 10 microfarad, and the question here is, let me take another color. So question is given like this: in the following circuit, okay, they have given the condition if Vc of 0 is 0, okay, find I of 0 plus d by dt of I of 0 plus and d square I by dt square of 0 plus if switch K is closed. If switch K is closed, okay, so by looking into this question here, so this is the given circuit. So what is the indication of the switch here? So if you look in, if you observe the switch, it is closing at t equal to 0, right? And it will closed, or it will for t greater than 0. So that means, or it is equal to infinity, right? So what we followed initially, we also recalled the condition of the circuit before the switch operation. Okay, so first thing is what you have to do here: when switch is open, so if switch is open, that means for t equal to which condition we have to evaluate here?
0 minus.
0 minus.
0 minus.
0 minus. So for t equal to 0 minus, we have to draw the equivalent circuit. Okay, so if you draw the equivalent circuit, and here you see that they have not given any statement like circuit is under steady state, right? So it is not mentioned. So only thing what they have mentioned is Vc of 0 is 0. Okay, okay, fine. So that means at this condition, if you check this circuit, 10 volts, circuit will be like this for t 0 minus. First you write the things as it is. So current will be I of 0 minus. So since the circuit is open, will there be any current now? What will be I of 0 minus?
0.
It will be 0.
0.
0.
So current through each component here, sorry, R, L and C. That means IL 0 minus will be 0, and as well as current through capacitor will also be 0, and uh, since current is 0, so what you can say, it will be behaving like open circuit. So will there be any voltage Vc of 0 minus? It is open here, this end is also open, If no current is flowing here means resistor will be open, this will be open, right? So this will also be 0 only. Okay, now you have to analyze which condition, given condition, find I of,
equal to 0.
yeah, so you have to close the switch first. So if you close the switch, so it looks like this. Resistor, so K is closed at t equal to 0. Okay, so when switch is closed at t equal to 0, inductor, what we had, inductor will act like what now?
Open circuit.
Yes, so this inductor will act like open circuit and capacitor will act like a short circuit. So capacitor will be circuit. So here you consider this as I of 0. Okay, and they have already mentioned Vc of 0 is 0. So keeping this in mind, if you write KVL equation, okay, it is open means physically inductor will be there but no current will flow. Okay, so if you just consider the values, so what we get is -10 plus r into, let us write just I first. Okay, then okay, just a minute, we'll be back. Okay, so if you write the KVL equation, so what you will be getting is L into di by dt, okay, plus 1 by C into integration of I dt equal to 0. This is the normal equation what we expect. Okay, then if you rewrite, and now if you keep this into steady state condition, okay, so what I can write, 10 is equal to R of 0 plus L into d by dt of I of 0 plus 1 by C integration of I of 0 plus dt. Okay, so we know the conditions here, right? That is no current through resistor, so R into 0, inductor value is 1, di 0 by dt I can write, plus 1 by C, so this is 0, right? So you can evaluate di by dt of 0 plus, so that turns out to be 10 amperes per second. Okay, is that clear now? So second step, how do you find it? This one, I of 0 we have found already, this one is over. To find this, what you have to do? Hmm. Yes, so to find that, what you need to do?
Differentiating.
Yes.
Differentiate.
Yeah, you need to differentiate which equation? This one? This one or this one? Both are same, right?
Yes, sir.
Second one, if you prefer, okay. So if you differentiate that again, so what you get, this will be 0. So if I write it directly, okay. So if you differentiate, 10 means it will be 0. R into I was there. If you take it at 0 plus R into d by dt of I of 0 plus, what we get, right? Next we had L into di by dt. So I can write L into d square I by dt square at 0 plus. Then 1 by c was there, then integration will cancel out, so you will get I of 0 plus, right? Okay, then out of this, which value we know? We know this value. Okay, so R is how much? R is 10 into 10. Inductor is 1 d square I 0 plus divided by dt square plus 1 by c. I 0 plus c is how much? 0, equal to 0. So if you evaluate d square I by dt square of 0 plus, that will give you minus 100 ampere per second square. Okay, is that clear now?
Yes,
Yes,
sir.
Yes, sir.
Okay, so next question number 6c, it is on Laplace transform. Okay, so question is like this: find I of t. Find I of t. So now for you people, there will be no confusion, because Laplace transform comes under which module? Module number 4. Okay. So module number 4 means question number 7 and 8, right? Question number 7 and 8, they will be specifically on Laplace transform. But earlier it was not like that. You need to identify. So now the things are simple for you anyway. Okay, so find I of t for the following network. They have given if k is open, if k is opened at t equal to 0. Before that, circuit has attained steady state condition. Okay, so they have given for that circuit is in steady state condition. So let us check the circuit what we have. We have the voltage V, then inductor L, then a resistor R1, then another resistor is there, that is R2, then you have the switch K. Okay, so switch K is opened at t equal to 0. So this is the given circuit. Okay, now if you consider the conditions here, when the circuit is under, okay, let us, this is the thing at t equal to 0. Before that, circuit is under steady state means what? When we have the condition at t equal to
Infinity.
0.
0, t equal to 0 minus.
Minus.
So we need to find I of t if k is opened at t equal to 0. Okay. So steady state is achieved before this. So we have to find when the switch is open. So if you take that thing into consideration, when the circuit is under steady state, okay, so at t equal to 0 minus, what will be the switch condition? K will be open or closed? See, always remember whatever switch condition they give, that will be at t equal to 0. If initially it is opened, so that means at t equal to 0 minus, it will be or it should be closed. So it will be closed. So if switch is closed, which will make the circuit to attain the steady state condition, here what you can say, inductor will act like what? Short circuit or open circuit? Previous many problems were solved, no? Just recall. Inductor will be acting
Short
like a
circuit.
Short.
short circuit
Short circuit.
when K is closed. Okay, so it will not be open circuit. Okay, so if inductor is acting like an open circuit, so we can Okay, so am I audible?
Yes, sir.
Okay, sorry for the interruption. Okay, so I think previously written materials were not saved. Okay, so anyway, uh, yes, I think I was drawing that equivalent circuit, right?
Yes, sir.
Yes, sir. So now let me finish it fast. So as we observed uh, earlier, so here now, so equivalently we will be getting this anyway. So that is okay. When the switch is closed, okay, so we know that under this condition the inductor will act like what now? Short circuit under steady state. Okay, so if you take that thing into consideration, so what we will be left with? We will be left with this, and you will be having R2 switch is closed here, right? Okay.
Yes, sir.
If you consider this condition for I of 0 minus, see here, since the switch is closed, one thing is inductor will be acting like short circuit. Another thing is this current, whatever it flows at this point, it has two paths. One is having some resistance, and another path is short circuit. Short circuit path always uh, gives zero resistance, so the current through R2, it tends to flow through this short circuit path, so the current will flow like this. Okay, so under this condition this resistor R2 will be neglected, open circuit. Okay, so now if you draw that equivalent circuit, so what we get is V, inductor is there but acting like a short circuit, then resistor R1 will be there. So this will be the new equivalent circuit. Okay, so I of 0 minus will be how much? I equal to V by R1. So we know that current through inductor cannot change instantaneously. So IL 0 minus will be equal to IL 0 plus, that will be equal to, so when the general equation for the network, if you take, so if you take this original network back, and if you write the generalized equation, what we can write is V is equal to R1 plus R2 into I plus L into di by dt. So this is our first analysis once the for t equal to 0 minus. So is that clear now? Okay. Now if you write the general equation once the switch is open, okay, so we get this equation over here. Let me call it as equation number 1. And if you take the
Yes,
Laplace
sir.
transform of, if we take the Laplace transform of this, voltage is constant, we can write it as V by S, then R1 plus R2, you can take it outside. I, we can write it as I of S plus inductor, you can take di by dt. So initially what we get, the current is V by R1. Okay. So how we used to solve for the later conditions, if you remember, I will get back to that point, but I am giving you one more approach here. So it will be like this: I of s minus I of 0 minus. Okay, this is the equation, but how do we replace the inductor? In value is how much? It was 1 L only. Okay. So whatever voltage we are getting, whatever current we are getting, that we used to express in terms of the inductor current. Do you remember or no that one? So
Yes,
now
sir.
if you want to have the voltage, what will be the voltage value, voltage source value? Hmm. So this one we have solved as a derivation, if you remember, right? So can you refer to that so that I can cover few more questions due to that interruption? So we have covered this under which condition? Behavior of inductor and capacitor under DC source. So there I have covered, so please refer to that. Okay. So finally what we expect, so there I have taken only one resistor RL circuit, right? Here you have one additional R, so that will be added up there. Okay. So anyway, so I will send this solution once again to you, starting from the beginning. So other two questions what they have asked is question number 7A. So is that okay now? So they have
Okay.
asked to find the Laplace transform of this. Okay, which has the magnitude A and minus A, 0t, 2t, 3t and 4t. So now if they ask you to find the Laplace transform of this, then by observation, first you tell me whether it is periodic or non-periodic signal. The pulse is repeating, right? So the wave is repeating. So with what is the time period here? So this thing is repeating, right? Here to here. Again you can see 2t to 4t. So the total time is, you can check, 2t minus 0 is 2t. So that means what here? So just you have to analyze this or synthesize this only for this much period, 0 to 2t and t. Okay. So if you take that, what will be the f of t value here? Now you tell me. Yes, quickly, we don't have much time. So start from here. What is the magnitude? 0.
0.
So change in magnitude is happening at which point? 0. And what is that change? Plus a, right? So 0 to a you have to go. So that means a into u of t. Okay. Then this is remaining till point t. So at t there is a change. So what is the change now? Here to here it has to go. You have to reach minus a at point t. So that means at u of t minus t there is a change in magnitude. So previously it was a, now you need minus a. So how much you have to add or subtract here?
-1.
No, we are at a, we want minus a. So you have
Minus 2a.
-2.
minus 2a. Okay. Then come here. So it is at minus a till 2t. At 2t it should be maintained as 0. So one more change is happening at u of t minus 2t. Now how much you have to add? Now don't look into this value here. Don't see these values. Check these values. You were at minus a. Now what you want is 0. Minus a to 0. If you want to make minus a to 0. So you have to add plus a. Okay. So this Laplace transform you can take, but since it is a periodic one, so how we have to describe it? F of s will be equal to f dash of s divided by 1 minus e to the power st. So t value is 2t, you can write 2ts. So this function will be what? A by s minus 2a by s into e to the power minus ts plus a by s into e to the power minus ts. This one. Getting this? So this was asked for 7 marks. So sometimes it may be extended for 10 marks also. Okay. Okay, so we shall stop here and we'll continue the discussion tomorrow.